All right, I gotta have some coffee and then we'll start. Hi. This is Monday, it's April break. I'm here at school. I might be the only one here, I'm not sure. It's pretty quiet, so I figured it'd be a good day to do some filming. Behind me, I have the Swifty CNC machine here. This is our 1250 Swifty. That rhymes, I didn't intend on that. And we're gonna use this machine to bevel plates. Now, this machine was not intended to bevel, but I built a fixture that will allow us to do bevels on this. Even though I do a lot of training here to AWS spec, we've got Bath Iron Works down over the hill. Bath Iron Works is a General Dynamics company. You can look up gdbiw.com, see what they do if you're interested in learning a little bit more about BIW. But basically, because it's a mil-spec facility, the testing requirements are different, and of course the tests are different. Most of the AWS tests that we prepare for in school, or even if you went for a main DOT bridge test, or you went down to Chimbro or Read and Read or whatever to take a hiring test, the test plates are short. They're 6 or 7 inches long, maybe shorter on the thicker plate, but at BIW they're a foot long. They're back gouged, and they require bevel prep that I just can't do on the bandsaw. Up until this point, any student that has been interested in going to BIW has had to bevel plates manually with a torch, or I've done it for them. I don't spend a ton of time on torch cutting, so a lot of students aren't comfortable cutting double bevel plates to create a double V joint. But ultimately, it's cutting and grinding to get that plate in shape. Well, now with the Swifty, we have the ability to do that a little bit faster. So there's a fixture that locks onto the machine, and basically we zero that machine out onto a locating hole in the fixture, and then you just hit go and it just cuts the bevel automatically. And you just keep repeating until you've beveled, both edges. I typically bevel both sides of the plate, so when we cut it to reuse it, we can just flip it around and reuse the outside edge. But I want to show you how to do that, and this is really more for the students than for anyone else. I have students use it on occasion, but realistically, in order to make full use out of this machine, you have to know how to use AutoCAD, or at least a professional version of Google SketchUp or something similar. So it's really outside of the scope of what I teach. But as far as having challenge assemblies that there are programs for, students should be able to put the piece of steel on, load the program, zero the machine, hit go. And that's basically what we're going to do today. All right, so the first thing we've got to do is turn the machine on. Typically, it will be off. The computer's closed. There's no light right here. The plasma cutter down there is off, and the machine is parked. The first step is really coming around the back side, and I'm going to reach around here. There's the power box, and I'm simply going to reach down with my hand and press this little button. But this is hard to do without dropping the camera. And when we come around to the front, sorry for this roller coaster ride, the light is lit up here as well. The next step is going to be to get the computer up and running. Now, you may not have to go through all these steps. Sometimes it's already running, but I've shut everything down. I use the mouse instead of this wheel. All this works. This isn't deactivated, but you'll find that your hands will get wet when you're handling parts, and then your finger kind of sticks to this. So it's up to you, but I just use the computer as a mouse wheel. At any rate, you want to click. You are logging into, I'm going to move this up, Swifty CNC. So that is the operator that you're going to be using when you're logging in. The password, the pin is simply 7018, 7018, and you won't see that on the screen, but we're a welding shop and 7018 just seemed kind of natural. On the screen, in the upper left corner, you have Swifty CNC. Now, if you take a look at this, there are two Swifty icons here. One is Swifty 1250 CNC and the other is just Swifty. The Swifty will bring you to the CAM software, the computer-aided manufacturer software. So if you're making a part from scratch and you're importing a CAD drawing, that's what you need. You don't need that in order to bevel parts. So I'm just going to double-click this, and this will load up. Now, at the main screen here, we have, in the bottom corner is Machine Enable, which we have to do, but in the right corner we have this message as an error message. So down below the front we have the e-stop. So I'm going to clear this by simply rotating it in the direction of the arrows, and you'll notice that that message is now says e-stop cleared. Now we have the ability to enable the machine. So I'm going to click on Machine Enable with my mouse, and then I'm going to come up here and I'm going to click on Reference All. Okay, the Reference All function, if I can find the mouse, this is fun without my glasses. Reference All will take the head and it will drive it into the position it's already in. It's really going into the back left corner. I'm going to jog this out. I'm just going to move the head real quick. And then again, I'm going to hit Reference All a second time. So I've got my mouse on Reference All, and I'm going to pan up a little bit, and when I press it, you'll see the head will go back into the corner. You'll also see that these X, Y, and Z axis will turn green once the machine has found the extreme back and the extreme upper travel on the Z axis. That has to happen before you can do anything. Once that has happened, you now have on the screen, you have a, and I can zoom in and out. My mouse wheel will allow me to zoom this in and out. Again, mice are awesome, touchpads suck. But I can move that around, and I can click the mouse button, and I can drag, and I can pan this screen. But essentially, that yellow box is the table. Now that is the usable area of the table. There are small notches in the table, and I'll take a look kind of here at the back corner, but they're in all four corners. And if you look at the table right there, you see a small notch just below the torch head, and on the left-hand side, right there, zoomed in, you can just see in the center of the screen there's a small notch. Those notches indicate the areas of the cutting table that are not accessible to the torch head. So basically on this screen, let me get back here. Sorry, this is amateur hour, but it is what it is. On this screen, as I move around, I can click on Run. I have options here. I can go to Jog, which is where I am now. The jog speed can be changed from 1%, which is like barely moving. You can see that I've held this down and I've only traveled about not even a ½ inch yet. But essentially, it goes from 1%, 5, 10, 50, and 100. So if I move this up to 100%, the torch is going to travel really fast, okay? I typically run the jog at about 50% max. But you can see now where the torch the head is moved. It is in that position. If I back up from the table, probably easier just to pick this up. You can see now where the head is in the middle of the table. So as I move that around, I will have a visual reference on the screen as to where the head's moving. Of course, you can just look left and right and see it. But as I drive this around, that will move. So that corner of that red mark will always be where the torch is. So now it's in the middle, and as you can see here, it is in the middle. So that's important because we have to put the fixture on here, and then we have to zero this machine out. All right, I've got the fixture here, and there are two parts to the fixture. This is simply the locating piece. This allows you to make sure that the plate is in the correct position before you cut. The actual fixture itself is right here. Now, this is large and it's heavy, but it is what it is. This makes the cuts out in the center of the table. It allows the strips to be cut off between the supports that are underwater, so that the long strips that you cut land in the deepest part of the table instead of piling up and sticking out and getting in the way. But if we take a look at this fixture, you'll notice, I'm going to pick this up, turn it around. that this edge right here is clean. This goes in the track on the edge of the table. The back side of this fixture is also clean. The rest of it's been painted. So basically what I'm going to do is I'm going to place this on the table so that these two locating parts that stick out are up against the front edge of the table, closest to you, and this is in the track on the right-hand side. So I'm going to set this down and then I'll get a closer look and we'll put this on location. All right, now the first thing I have to do in order to use this is I have to pull the 2nd and 7th support strip out of the table. These will be in the way. So I'm simply going to pull these out, set them off to the back. So that's 2, 3, 4, 5, 6, 7. And these just simply lift out. That gives clearance for the welds on the back side here, and it gives clearance so that we're not cutting through that every time we make a cut. So I'm simply going to place this on right now. I want this right here to be buried in this track between the aluminum and the part that's painted orange. Okay, and that's what we're looking for. So we have to make sure that it's placed nice and secure. And again, don't pinch your fingers. I'm going to get that in there. I'm going to kind of get it up against the front edge of the table first. So I'm really looking here. I know this is an awkward camera shot, and then I'm going to drop it down in place. So I want to kind of hold it forward up against the front edge of the table, and then I can drop it down in place. And that's going to locate this so that it is parallel and square, and it will allow us to take the plates on and off the machine without losing our orientation. Okay, this part right here is got 2 pins on the back of it that lock into these 2 holes. So this has to be placed on like so. Once we put the plate to be beveled on the magnet assembly, it has to be placed down against these 2 guides, and then all the way to the left against this support right here. Okay, so we'll go ahead and set a plate on there. I'm simply going to set that on the magnet, okay, and I'm going to make sure I push it all the way to the left and all the way down. So I'm going to tap it down, tap it to the left. It is now in position to be cut. This has to be removed, okay? So you have to pick it up from the rear. It will tip up this way, and it will come out. If you try to pick it up frontwards, the plate will be in the way. So simply, again, grab that, and I'll demonstrate this process again, kind of real time. So every time you make a cut, place the fixture on, put the plate up here. We're going to slide this down, tap it to the left, and then again, pick this up from the back, and it's ready to bevel, okay? So what we have to do now is get the correct parts on the machine, zero the machine out, and then we're ready to cut. Now, I'm going to use the jog function on the screen, and again, I'll come over here so we have a view of both at the same time, although this isn't ideal. But I'm going to grab the mouse, or you can use your finger if you want, and I'm going to simply drive this head down, and I'm going to bring this over above the fixture, being careful not to crash it. Now there's a location hole in the front of the fixture. This hole right here is where we're going to zero. But right now, this has the wrong parts. This has the fine cut consumables on it. So we're going to swap those out, right? Now, normally when you're swapping parts out in process, you would come to the screen here and you would go to the Run tab and you click on Consumable Change. Now that's not necessary to do that, but when I do that, what will happen is it will drive the machine over to a neutral point in the middle of the table, and that point is accessible. Conveniently here, it's over the fixture, so if you drop parts, they don't go into the drink. So at this point, I'm going to swap these out. Now this is something you have to check. The last material we cut on this was 14 gauge, so this has the fine cut consumables. So we can't cut 3/4 inch plate with the fine cut consumables. The fine cut consumables can be identified pretty easily because there's no shield covering it. There's a thread protector here. This part simply protects the threads on the body here, but the nozzle itself is radiused, and again, it's exposed. So it makes it a little bit shorter, and you just can't cut thick plate with this. So I'm going to take this apart. Again, if you're not familiar with operating the plasma cutter, that's another video. But I'm going to take this apart, and what I have to make sure I swap out is the actual nozzle right here and the swirl ring. Now the swirl ring says right on it, if the camera will focus, if I can get it to focus, I can't even see because my glasses, it says fine cut right on it. So those parts are stored in the file cabinet that's over here behind, right in that cabinet, or more commonly, right behind the computer. So if I swap those parts out for a quick cut, I'll often just place the fine cut or the normal parts right behind the computer. So that's the first place I would go to look. So I'm gonna swap those out. Again, the swirl ring simply pushes up into the torch body, and it'll only go in one way. It'll stay put by itself. After that, I'm going to take the nozzle, and this nozzle is fine. There's nothing wrong with it. Make sure it's a 65 amp nozzle, not a 45 amp nozzle. We do have a 45 amp machine in the shop, so we have to have the correct nozzle. The electrode is in good shape. I know this is out of focus. This is horrible trying to do this, get this thing to focus. But the electrode tip is, not worn back more than the 1/16 of an inch. It can look pretty bad, folks, and it'll still cut just fine. That drops in, and then we thread this up into the torch body, and then we can put on the mechanized shield. I'm simply going to thread this up in. And then the mechanized shield is this shield right here. Again, this is a protective cap. If this is a little bit messed up, the holes are a little bit plugged, it will still cut just fine. It's basically there to ensure that when you pierce through the part, the spray that comes back up, right? That was kind of scary. The spray that comes back up until it pierces through doesn't damage the nozzle. For this operation, we're not piercing through the part, we're starting to cut on the edge. So basically what I'm going to do is I'm going to drive that tapered nozzle into that hole. So initially, I'm going to click on my jog settings on the tape on the computer, and I'm going to drive this over, and I'm just going to get it somewhere in the ballpark, and I'm at 50%. And again, movements are going to be pretty coarse at 50%. So once it's close, I'm going to turn that down to say 10%, try to get it roughly over the hole, bring the Z down, I'll drop it to 5%, just getting finer and finer control. And again, that's a minimal movement at 5%, right? So it's not really still small movements. I'm going to drop it to 1%. And now I can fine tune that and click it around. Now the Z-axis is going down. You can hear it more than you can see it, but if you watch the screen, you can see the numbers getting smaller. And what I'm looking at is this gap. Okay, I'm going to zoom in here real close because I'm pretty close right now. I'm really looking at the gap around that torch. And I can see that that gap is wider in the back edge. Right over here, it's almost touching. So I'm just really going to try to just kind of move the X and move the Y back and forth and move the Z down. And then I'm going to get close. Again, I'm going to come over here. I'm going to take my glasses off so I can see. The gap is reasonably uniform. It might be slightly wider in the back. So again, I'm just going to give it one click in the Y. Again, I'm at 1%, so that's as fine as I can get. And then I can drive this down a little bit deeper in the Z. And now it looks like I have a pretty uniform gap all the way around. So I'm going to call that 0. I'm going to come over here and I'm going to hit 0 XY. I'm never going to hit 0 Z. The machine does not need to have the Z-axis zeroed. There's a soft sense feature. It will detect the surface of the plate and it will know where the reference 0 is on its own. So just hit 0 XY, okay? Now I don't want to move this because I will crash the head. Now this head is on a magnet, so if it does hit something, it simply kind of pops free, okay? And it will give an error. And I just created that error right here. So breakaway head condition cleared, okay? And then that forces me to have to re-hit machine enable, okay? Now I can go back and I can operate as normal, but we don't want that to happen. So again, I'm going to turn my jog speed up and I'm going to raise the Z up just to get it out of the hole. At this point, basically we're ready to cut, except we have to load the program to do that. So the machine is zeroed. We have a plate on there ready to go. We'll load the program. We'll of course turn on the plasma cutter and we're ready to cut. All right, at this point we have to turn the plasma cutter on. Now, click, there, I just turned it on. So you look down below, you see that the machine is lit up. Everything's green. Now the switch is actually on the back side, but I want to just demonstrate something here quick. This may be the first time you've run this machine. So we just swapped out the parts on the head. Now, what I'm going to do is I'm going to loosen this as if I was changing parts out again. If I can get my hand in here. It's hard getting out of my own way. Okay, as soon as I loosen that, I don't even have to take it all the way off. I now have a yellow fault light on the machine. Okay, so there's a light that's lit up down here, and that light right there is showing an error. Okay, that is a fault. And essentially that fault in this particular case is telling me that parts are not in place. So had I turned the plasma cutter on in the very, very beginning, which I didn't, but I turned it on off camera. Once I swapped those parts out, even if they were the correct parts, but I just wanted to see, hey, is this nozzle messed up? Is the electrode worth anything? I would get a fault and I'd have to turn it on again. So I will typically not bother turning this on until after I've swapped parts out, because I'm going to have to turn around and turn it on and off again. So we've cycled it off and on. Again, it's a rotary switch on the back, and that part is ready to go. Okay, we are zeroed, and now we're going to load the proper program. So to load the program, we're going to click on Load G-Code down here in the corner. And now, most of the little parts that we cut, little doodads, are under shop projects, but the beveling fixture is not. I'm going to click on CNC files to go back a step. I'm going to click on shop parts, and then I have beveling jig. Now there's two programs. There's 30-degree double bevel 0.75 plate and 30-degree single bevel 0.75 plate. We're going to cut the double bevel. Now the setup for the single bevel would be exactly the same. The only difference up to this point was the program that we load, but I'm going to do the double bevels in this particular video. So I click on that, I come down here, I see that I have the file, and I simply click open. Okay. At this point, this thing is ready to cut. You can see on the main screen here, if I get out of the glare, that is the travel path. So this machine is actually, right now it's currently located here, this red. That's the bell. It's 10:25, so my first morning class would just be leaving right now. So right now it's parked right here on this corner. Again, if I move over and I click the jog function and I just move off, you can see that that's moved. I'm going to click Go to 0 just to kind of get back. I got to loosen this camera up a little bit. I'm going to go over here, click go to 0. You can see that it's going to travel back to where it was. It's now back over the 0 point. And I have a white line because it's moved. So I'm going to click refresh. So the path is going to be, it's going to leave the 0, it's going to jump over here in rapid travel, and then it's going to touch off, it's going to travel over, it's going to cut where the green line is, and then it's going to rapid out of the way, okay, on the back side. That is the travel path. So all I have to do at this point is simply come over here and hit run G code, okay? That's the magic to this, just run G code. The machine's going to touch off, and if the jig is in place, there is a line in the program that makes it travel to it first, so it will intentionally crash, as you can see here. That is stop the machine from cutting the jig off. Down here on the screen, we have, again, breakaway head condition. So we have to move this off after we enable the machine. So I'm going to hit machine enable. At that point, I can jog this left to get it off the head. It's moved away, and I can kind of rattle that head to make sure that it's back in a neutral position. Now, I'll remove this because that's the reminder, right? It just crashed. At this point, I've got to verify the 0 again, because when it breaks away, sometimes it'll move the head. This whole assembly can be pushed. So again, machine enable, and I'm going to hit go to 0. Can you speed that up a little bit? I'm going to drive this back down. I can see that it is actually not on center. It's off a little bit. So again, I'm going to very slowly creep this down to 1%, and I'm going to drive that back down into that hole. And the Z-axis moves real slow. The X and the Y seem to be faster. But I'm going to get this relined up and verify my 0. That way, if you forget and leave that jig on, you will not cut the end of the jig off, as I've done now myself and a student has done once. It's a very, very easy thing to do. So that is a fail-safe that's built into the program. And that is to help you. But again, if that does happen, don't just hit go, actually verify the 0. So I'm back in the hole, and I'm going to hit 0xy. Okay, so that is 0'd, and as I've shown previously, I'm going to raise this Z-axis back up. At this point, I'm again ready to recut. So I've reset my program, and I'm going to hit run G code. So that is intentional. You'll see it this time, it'll zigzag. That's not an error. That is Again, that's not a mistake. That's there specifically to prevent the jig from getting cut. So I'm going to flip this part over. I'm going to chip the dross off the back side. It does usually come off pretty easily, although occasionally it doesn't, as I can attest to. So we've got half of it beveled. Now we'll place this back on the fixture, make sure the magnets are clear. And again, we're going to replace this, and we're going to slide this down. Again, we'll pop this out, and we'll make our second cut. And that's our beveled plate. All right, so I want to talk about the two things that are likely to go wrong if there's an issue. This program requires that the plates be 12 inches long to begin with. And if they're not 12 inches long, or if they're torch cut, maybe one end is cut a little bit crooked, you could have a situation where either the machine goes up to strike an arc and there's no steel there because the plate, even though it's been shoved up against the stock, if the end is a little bit misaligned, it'll try to strike an arc where there's no plate. Or if the plate is short, it'll run out of steel that it's expecting to cut and it will get an arc lost error. The third thing that can go wrong is if a plate was cut long, if it doesn't cut it all the way off, the easiest thing is just to grab a cutoff wheel and just finish the last little bit of the cut. But for the other two, the fix is easy and it's on the machine. So let's look at those right now. All right, every now and then you're going to get a plate where the end is crooked or the plate is short. In this case, this plate was the very end of the piece of steel that came off the truck from American Steel. This had a little tag on it. It's sheared off. And when we get this material, this flat bar is 20 feet long and it's 3/4 by 6 by 20 feet. So it's pretty damn heavy. We will typically lay that on the ground and we will cut the 20-foot length in half, which means that somewhere along the line you're going to deal with a saw cut or an end cut, and you may have a piece that's a little short by the time we get them on the saw. What I want to show here is this plate is in fact 1/8 of an inch short. And what I'm going to do is I'm going to push this over so it's 1/8 inch off the stock approximately. And by doing that, I'm going to have a situation here where, I'm going to try to get it just about 1/8, where the machine will hopefully not strike an arc when it gets to the beginning. Sometimes if a cut is crooked, and this actually looks to be crooked as well, the machine will go over, it goes over to a specific point, tries to strike an arc, there's no metal there to hit, and it does not, and it creates an error. I'm going to show you how to clear that error. When I flip this around, I will put the saw cut end against the stock, and it should, in theory, run out of material to cut before it gets to the 12 inches, and that will create another error, and I'll show you how to clear that. Those are the two common things. So let's go ahead and we'll take a look at this. So first, the hope is that this does not strike an arc. Okay, that's what we're trying to get right now. I'm going to hit run G code. And again, don't look at this arc when you're cutting. So it did not strike an arc. Now, you can move this, but for the purpose of the video, I'm going to let this time out because I can't move the camera and show this at the same time. All right, there we go. So if you're doing this, you don't have to wait for that. You can simply come over here. You'll notice that machine enable is flashing, and down here it says arc OK, signal not detected. So I'm going to hit machine enable, and then I'm going to move the head out of the way. I don't necessarily have to bring it back home, but I have to move it in such a manner that I can get my fix in place. And it probably would be okay now, but the best bet is to hit reset and then hit go to 0. Kind of bring the machine back around to a neutral starting position. The fix, as you can see, I've already done this a few times, is to take some runoff tabs. In this case, I've got 3 runoff tabs. I'm simply going to stack them up next to the part, and I'm going to hold it, all the way back up in that corner, but I'm simply giving the machine something to hit electrically. It has to be touching the plate right here because everything else is painted and you won't have a good ground. So as long as that's there and that's touching the plate, and you notice I've got the top tab sticking out further than the rest of them so it doesn't have to pierce through 3/4 of an inch of material. And this should allow this to cut correctly. So again, I'm going to hit run G code and it should work correctly now. Well, it made it around. I'm not going to simulate this again. I've done this literally like 4 times already and had camera problems. But if it gets to the end of the plate and stops right here, it's basically run out of material, and it's expecting it to still be cutting, but yet there's nothing there for it to cut. Just simply hit run G code again, and it will pick up where it left off, and it will cycle back around. Those are the common errors. All right, so, and now the air compressor's on. All right, it's been a hell of a day. I have filmed what should have been a short video, and I think by the time it's edited and you see this, it won't be too long, at least for my videos. I filmed this at least 6 times. I have had everything go wrong that could go wrong. I had the camera at one point, I thought it was recording, and when I hit pause, it actually started recording, so I was recording my setups and I was not recording the footage. But hopefully this worked out to be pretty good, and in terms of the context of this specifically for the class, if you got questions, come see me. But to recap, all right, when you first come in, you're going to go around to the back of the machine and you're going to turn that on. Power switch clear on the back side around the corner. You're going to release the emergency stop right over here, and then you're going to open up the laptop and you're going to log in. Again, the password is 7018. You're logging into the CNC operator, okay, not the other 2 profiles that are on there. You're going to open the Swifty CNC 1250 icon. That will bring you up to the main machine, at which point you have to enable the machine after clearing the e-stop. You have to hit reference all so it knows where it is, and then you can put the fixture on the machine. Again, we have to bring the fixture all the way to the front so the 2 arms are touching near you, and then lower it down so that the side kind of goes into position. We're going to zero the machine out by locating the center of the hole. Then we're going to put the locating fixture on. We're going to drop on the plate, remove the locating fixture, remembering if you forget to remove it, the machine will crash into it, and you'll have to re-enable the machine, breakaway head condition, and then you should definitely check the 0 because it may have moved. It may cause some bad cuts. If you get a plate that's a little wonky, or maybe it wasn't pushed over all the way to the side, or maybe it was cut incorrectly or poorly, wrong length, and it doesn't start the cut, simply stack up some tabs so it has something to strike an arc to. And if you get a plate that is short and it stops, I try to show that at the end here, but of course it worked when I didn't want it to work, and it's 4 o'clock and I've been here since 9 o'clock this morning. Then at that point, you're just going to hit run G code again, and it will literally pick up where it left off, and it will go back around. This should be relatively straightforward, and I have this sense that it's not, but we'll see how the editing works out, and hopefully by the time you get to this point, you'll be like, oh, that actually was a pretty good video. I don't know what you're talking about, Mr. Carter. Keep my fingers crossed. Bye.